to our class. I still remain my humble self, Mr. Yunusa Kasim Abiodun. Our class, mathematics class. Then we've been talking about circle geometry. Like I said in the last video, that we are going to proceed to the examples on the first theorem. That the first theorem, that is a straight line drawn from the center of a circle to bisect a chord which is not in diameter is at right angle to the chord. So this is our first example. Example 1 is telling us that PQ is a chord of a circle. The radius of the circle is 10 cm and the distance of the midpoint of this chord from the center of the circle 0 is 6 cm. Calculate the length of the chord PQ. And the second question, calculate the angle chord PQ subtends at the center of the circle. Now let's proceed to the problem, to the solution. This is what? Solution. It is solution. It is not soluki. Alright, now PQ is a chord. That shows we have a circle like this. If we have a circle like this, circle center 0, then PQ is a chord. I've explained this in the first theorem. In the first video, that a straight line that is joining any 2 points of a circumference of a circle together is known as a chord. So PQ is a chord of a circle. The radius of a chord is 10 cm. The radius of the chord is given to be what? 10 cm. And I've explained also in the first video that the radius is a line from the center of a circle to any point of the circumference of a circle. Also, the question proceeds by saying, and the distance of the midpoint of the chord from the center of the circle. So the distance of the midpoint of the chord from the center of the circle is given to be what? 6 cm. Now, what are we looking for? We are looking for to calculate the length of the chord PQ. We are looking for this PQ. Now let me just say this place to be N. So if this is N, then I can bring out this triangle by saying this triangle is like this. If this triangle is like this, this is P, this is 0, this is N, and this is what? 10 cm. Why are we bringing this one out? Don't forget in the last video, I've explained that this line that is coming from the center of a circle will bisect the chord into 2 equal parts. Then, what is this angle? This angle is a right angle. Why is it a right angle? It's from that first theorem that is telling us that any line that is drawn from the center of a circle to bisect a chord will automatically be perpendicular to the chord. We've proved that in our last theorem. So meaning that this is what? 90 degrees. What are we dealing with? That's just we are dealing with what? A right angle triangle PNO or ONP. That's what we are dealing with now. And when we are dealing with a right angle triangle, we want to find the side of a right angle triangle. If 2 sides is given and we are looking for the third one, it shows we are going to make use of what is known as what? A Pythagoras theorem. A Pythagoras theorem. And what is the Pythagoras theorem? Pythagoras theorem states that the scale of the hypotenuse is equals to the sum of the square of the other 2 sides. Is equal to the sum of the square of the other 2 sides. That's why I can say this one is 10 square equals to Pn square plus C square. C square. My 10, why is it an hypotenuse? Let me quickly explain that too. That hypotenuse is a line that is facing the right angle, that is facing the angle 90. Some teachers will define this as the longest side of a triangle. Now, I'm not saying it's not correct. It is correct. But at times, some students find it difficult to identify the longest side of the triangle. So it's better to put it in this way. That hypotenuse is the side or the line that is facing the right angle. Then some will be confused that why am I not writing hypotenuse square equals to opposite square plus adjacent square? Don't forget in there, not all the triangle that we can determine the opposite and adjacent. It's just when in a right angle triangle, when one angle is given, that is when we can determine the opposite and then what? And adjacent. And that is why the theorem is not telling us that hypotenuse square equals to opposite square plus adjacent square. The theorem is telling us that the Pythagoras theorem is the scale of the hypotenuse is equal to the sum of the square of the other 2 sides. Now let's proceed to our problem. So let's proceed to our solution. Our solution. So this is going to give us what? 100 equals to Pn square plus can now collect the like times by saying our Pn square equals to 100 minus 36. So what's going to be our Pn square? Our Pn square will now be what? Our Pn square will now be what? 64. And when we are there with the square, we want to remove square. That means we're going to find the square root of the both sides. So the square root of Pn all square. Just like this and this we cancel, equals to square root of 64. We can say plus or minus 64. Equals to plus or minus 64. That shows our Pn. Our Pn equals to plus or minus 8 centimeter. Then why are we doing this? When we are looking for the square root of both sides, it is plus or minus. But as we say, our answer is Pn equals to plus 8 centimeter. Some may be asking, why am I not making use of negative? Because when they ask you to measure something, you can't measure it in negative. When they ask you to find, to go and measure something, or to go and measure anything, it can never be in negative. It can only be in positive. That is why our Pn will now be what? 8 centimeter. And don't forget that thing is asking us, that question is asking us to calculate the length of the chord. To calculate the length of the chord. We want to calculate the length of the chord PQ. And we cannot say our PQ equals to 2 Pn. Reason because we have explained that this line that is coming from the center of the circle will divide the chord into 2 equal parts. Meaning that the length of our PQ will now be what? 2 times 8 centimeter. Meaning that our PQ equals to what? 16 centimeter. 16 centimeter. Let's proceed to the B aspect.